start this recording. Everything's good. Weird. Okay. So the practice test, we're not doing the practice test together until the review day. I think the review day next Wednesday. So it's a week out, don't worry. But what you're gonna do is you're gonna do this for practice, right, before the review day, and then you'll show me at the start of class that you tried it. It doesn't have to be right, it's just for completion marks, and that'll count as one assignment mark. Okay. And so easy 100% on an assignment, right? Either did it or you didn't do it, right? And it'll just be automatic 100%, right? So, and then we'll go through it together. But at least if you've tried it, then you'll know where you had troubles, or if I say something and you're like, oh, weird, that's not what I thought at all. That helps too, right? So at least if you've tried it, that's why I wanted to give it to you a little bit in advance, so you have the weekend to enjoy it, or the weekend to not do it. I posted a lot of assignments the other day, didn't I? I was gonna, so I started and I made an assignment and it was just gonna be one long assignment, but then I thought, no, I'll break them up into smaller assignments, and then all the assignments will be worth less, right? Each of the assignments will be worth a little bit less if I have lots of them. So that's my logic there. Because then if you forget to do one later on, right, these first ones will be nice and quick. If you forget to do one later on, it won't be worth as much. That was my logic. Okay. So I think I posted 4 assignments. Could have been one long one. All would have been the same, right? But make sure you do all the assignments posted on Moodle. I think assignments 1, 2, and 3 are due next Wednesday on the 30th. To January 30th, is that, yeah? At 11:59 p.m., essentially midnight. Midnight gets confusing though. Is it the beginning of the day or the end of the day? Ugh. Right, and so at 23:59. Okay. And then I gave you a little bit of time. You can do assignment 4 now. I just wanted to give you a little bit more time. Do February 4th? Thanks. Should be at the same time. 23:59. Great. And then I'll post another assignment from the stuff that we're about to do today. But again, I'm gonna try to keep them nice and short. There's some quick ones. Try to do between 5 and 10 questions for each assignment, so they're not too bad. Okay. Let's do a little bit of review before we, although it was just on Monday that we met, so should all be kind of fresh. Right? We finished off linear programming, which you'll see is the first big question on your practice test. As far as the practice versus the actual test, you can expect to see something like this on the real test, right, on test 1. But of course, we'll talk more about it in the review day. So, review. We talked about merchandising. Some key formulas that we introduced were N is L times 1 minus D1 times 1 minus D2, all the way up to 1 minus DK. We have another formula on there, but it's just the mini version of this, right? That's just if you have one discount. So this one applies to both of them. Okay. And then we said, well, there's lots of ways that we could figure it out, but our go-to formula for S is going to be C plus E plus P, where we said C was the cost, or I should start with S, right? S was the selling price. C is the cost for the store to acquire this product. Right? E was the overhead expenses, right? Or the expenses that they have to pay. And then P is the profit. So we outlined all those last day, so I won't write them down again. I won't. And then we briefly talked about the ROMU is the rate of the markup. And we said we have two ways of calculating it. And same thing for the gross profit margin is the gross profit margin. If you're looking at your formula sheet, you'll notice we covered a lot of these formulas last day. Right? So today we're just going to finish off the SR formula and the ROMD, the rate of the markdown. Okay? And then that'll be it for the merchandising section. And then today we'll move into the CVP analysis. Okay? What you'll notice for test one only covers the first two sections. So it covers merchandising and CVP analysis as far as the formula sheet goes. Okay. So, any questions about the stuff from last day before we finish up this merchandising section? Okay. All good? All right. Markdowns. So a markdown is a reduction in the selling price, right? So something's been marked down some amount. So a markdown is a reduction in the selling price of an item. In the selling price of an item. So what we did last day was we just had a look at the formula sheet, and then I'll just write out what each of these things are again, right? So S subscript R is the reduced selling price. We'll start there. So S subscript R is the reduced selling price right? So this is the price after a markdown. S, just so we have a reminder, it's going to be important. That's just the original selling price, right? It's the selling price. But in terms of this formula, right, it's the original selling price. And then we have the ROMD, or the ROMD. Doesn't sound that good, but it's the rate of the markdown. Usually it's given as a percentage, but we have to use the decimal version. So usually given as a percentage, but we must use the decimal in our calculations. This isn't the first time that we've seen something like this, right? Where we usually talk about a percentage, but then when we're calculating with it, right, like taxes, for example, we have to use the decimal. Right? So it's pretty common. And then if we have to calculate the rate of the markdown or the ROMDA, oops, I already did that. We need to talk about D, right? Moving on to the next formula, the ROMDA is D over S, where D is the amount of the discount. Right? So a dollar value. And of course, S is the selling price again. So we have these formulas. We have SR is S times 1 minus the rate of the markdown. I promised I would try to remember to highlight the ones on your formula sheet. That's one more I remembered. That's pretty good. And also we've got the rate of the markdown is D over S. And again, that's on your formula sheet. So we'll just do a little example of this, and then we'll start the next section. So I'll do example 96. If you're following along in the textbook. The sign on a rack of sport coats reads, all prices marked down 30%. Great. What is the regular selling price of a coat marked at $100? And then another part, $196.49. Right, so we want to know what was the original selling price. So now we're looking at S. Right? So we're given that the rate of the markdown, right, that's our percentage of the markdown, is 0.3, right, or 30%. But we have to use the decimal, right? So that's why I said 0.3. All prices marked down 30%. So that's the rate of your markdown. And then we want to know what's the regular selling price, which means that these prices that are listed have to be the reduced selling price. So we'll start with the first one. The reduced selling price is 100, and then we have to find S. We'll do A first. We could use either formula, but I think it's going to be easier to use the first one, right? The one with the reduced selling price and the selling price and the rate of the markdown, because we have two pieces out of the three. Makes it really easy to solve for. The rate of the markdown with the D over S, right? D is the amount of the discount. So then you could figure out what D is and then figure out what S is. But I guess we're trying to find S. So we couldn't even do that. So we have to use this other formula. right? But that's how you can go through and see which formula is going to be easiest to use. Right? Just kind of map out, okay, well then I would need this, so I can't use that. Right? So we're going to use this formula, and in fact, I was wrong. It's our only option. The reduced selling price is S times 1 minus the rate of the markdown. So our reduced selling price is 100. We're trying to find S, and the rate of the markdown is 0.3. So 1 minus 0.3. If we simplify this, we get 100 is 0.70 times S. Right? 1 minus 0.3 is 0.7 times S. Solving for S, we get 100 divided by 0.7. So S must be 142.86. Can't remember. I did the rounding. Well, I must have done the rounding, or if it just worked out that way. 100 divided by 0.7. I'll do all my decimal places here quickly. 0.85711429. So the original selling price must be 142.86. For showing your work, if you just rounded right away, that's fine. I like to throw all the decimal places on there just so you can check your calculations, right? Just so you can make sure that you're getting the same answer. But if you just went to the rounded value, that's fine by me. So different for me and for you. You get to skip a step. How about B? So now we're given, so the rate of the markdown is still 30%. Right? So we can still say that. So given that the rate of the markdown is still 0.3, but now the reduced selling price is 196.49. And we're gonna find S again. Right, so same procedure, different number. So we know the reduced selling price is S times 1 minus the rate of the markdown. So we've got 196.49 is S times 1 minus 0.30. I paused. I was tempted to just do 0.7S right away. If you did, it would be fine. But I figured I should probably show all my work. So 196.49 is 0.7S. S must be 196.49 divided by 0.7. Hey, now we get an even number. $280.70. This formula looks a little bit familiar, right? From when we were dealing with those taxes, right? Because you have your original price at the restaurant, for example, right? That would still be S. But then we would do 1 plus the taxes, right? To figure out what the total bill would be. Right? So very similar situation, just we're adding taxes, we're taking away a markdown. Right? Any questions about that one? No. Yeah. So then, that's the end of that section. And so that was the merchandising section. So now we're going to do section 3.3, which is called What was merchandising? Could have sworn I wrote business economics last day. Did I? I swear I did. I don't know. Can't remember. I must have written it. Oh, and now 3.3 is also called business economics. Thank you. I knew I had written it down already. Well, section 3.3 is also called business economics. But in terms of the formula sheet, I'm going to call it CVP analysis. CVP, is it cost value profit or price? I can never remember. Hey Siri. Is it price or profit? Price? Awesome. Then I can write it down. Siri will know. Actually, we got a Google Home for Christmas. It's really fun. She's so clever. She knows everything. Also, have you guys played the game Bears versus Babies? It's really fun, and we asked Google about this weird rule, and she knew it. Sort of. It's really stupid, but it's really fun. You build like monsters. Anyways, doesn't matter. But she knew this really weird rule, so it's really handy. So I was sold. All right. Business economics. Back to the good stuff. So here, this section of our formula sheet looks a little bit different, right? It's a little bit smaller, but also there's things like the profit of X, right? So now we're essentially going to start building profit functions, okay? So in this section, we will build profit functions. Yeah. Profit? Final answer? Oh, it is? Don't listen to me. Good? Thank you. This whole time I thought it was value, because we're building profit functions, but thank you. Anyways, I know what to do. So we're going to build profit functions. Again, we need to develop some terminology, right? And so we'll just start with the fixed cost. So FC is the fixed cost. Okay. These are costs that you would have regardless of if you're making anything or if you're selling anything, right? So rent, your phone bills, right? So all those would be fixed costs. You have to pay them. Rent, they don't care if you're not selling anything. They still want their rent, right? So those are fixed costs. So costs that are independent of output. And then we'll have our variable costs, VC, which is your variable cost. These are costs that depend on how much you're putting out, right? So materials, wages, right? That type of thing. So it costs me $30 per item to make it, right? That would be a variable cost. And that's not including rent and all that fun stuff, right? We keep those separate. So costs that are dependent on the amount of output total cost then, TC. Well, it's the total cost. I don't know how else to say it. It's going to be the fixed cost plus the variable cost. Or if you look on your formula sheet, it'll say the total cost is the variable cost plus the fixed cost. That's the first one on your formula sheet. I'll move down each column. And so we have C, just looking ahead at the formula, VC is C times X, where C is the actual amount that it costs per unit. So C is the cost. Okay. So the cost to produce 1 unit. And lowercase x is the number of units. Number of units. And depending on the situation, it'll be the number of units that you've sold or the number of units that you've produced. So it depends, but it can be either or. Sold or produced. Usually in our problems, because they're a little bit simplified or really simplified, we assume that as soon as we make something, we're able to sell it right away. It's not really the case, but right, we just assume that they're the same. Okay. So our variable cost, VC, is C times X. And that's the one on your formula sheet. So your variable cost, right, because it depends on the number of units that you produce, it's the cost per unit times however many units you're selling or producing. Okay. Next thing we'll define is TR, your total revenue. Total revenue. So this is the amount of money that you've made, right? Just selling these things without taking away any costs. So the total amount made before deducting costs. And if you look on your formula sheet, right, you've got the total revenue is P times X. There's that X again. We've seen X. X is just the number of units. But P, a lowercase p, is the price that we're able to sell each unit at. Right? So P is the price per unit. I'll put in brackets the selling price. And if you think about it, right, the total revenue is, so if I say, oh, I sell these things for $10 a piece, I sold 5 of them, what's my total revenue? 10 times 5, 50, right? And so that's your total revenue. Okay. So we have this formula here. The total revenue is P times X. And that's on your formula sheet. So then, now we've landed at the last formula in this section, and that's the profit function. So in the broadest sense, your profit is your total revenue, right? How much you brought in from selling these things minus your total cost, right? However much it costs you to make it and produce stuff, right? And so that's how you find your profit. There's nothing else in between, right? How much you brought in, how much does it cost you? The rest is your profit, right? And so in general, your profit is the difference between the total revenue and the total cost. Between the total revenue and total cost. So on your formula sheet, you have the profit of X is TR minus TC. That's the last one in this section, right? A lot fewer formulas in this one. So knowing this, right, we can start filling in and making a bigger profit function, right? Because, for example, just looking here, we have the total revenue, but the total revenue can be replaced with P times X, right? So now we can find the profit in terms of how much can I charge per unit times how many units am I selling, right? And also the total cost, right, can be replaced by the variable cost plus the fixed cost, but also the variable cost can be replaced with the cost per unit times X, right? And so what we can do is we can kind of just balloon this formula out using the other formulas. Okay. So now we can develop a general profit function. A general profit function. The profit of X, that's a function, right? So it takes some value of X, it'll tell you what the profit is. I'll start with this total revenue minus the total cost. And then I'll slowly put in the other values from our formula sheet. Right? So what you'll do in this section is you'll start actually with the lower left-hand corner profit function, and then just kind of work your way around the formula sheet, filling in the gaps. Right? So you'll see what I mean here. So the total revenue, we can replace with P times X minus the total cost. But then we can replace the total cost with the variable cost plus the fixed cost. It's very important that we put those brackets on, right? Especially because we've got a negative out front. So the total cost is being replaced by the variable cost plus the fixed cost, right? So you don't want to lose that negative. Because what's going to happen when we expand the brackets, right? We get PX minus VC minus the fixed cost, right? So you don't want to be adding the fixed cost because, well, one, does that make sense? Right? You're trying to figure out what your profit is, and then you somehow get to add your fixed costs? No, not really, right? So you have to subtract those from your profit. And then finally, we can replace the variable cost, right, with that C times X. So PX minus C times X minus the fixed cost. We can factor some of this, right? We can collect the two like terms X's, pull them outside. So then we get X times P minus C, minus fixed cost. That's it. That's as far as we can take it, right? But now we have this general profit function, which is way better for calculations, right? Knowing that it's total revenue minus the total cost doesn't really get you anywhere. Right? Then now we can say, well, if X is the number of units, right, sold or produced, it doesn't really matter for our questions, times the amount that we can sell them for, minus however much it costs to make each one, right? So now this value is how much we actually bring in off of each unit, right? Because it's how much we sold it for minus how much it cost us to make it, right? Sold it for, cost to make it. And then finally, we have to subtract our fixed costs, right? Our rent, our utilities, all our bills, right? So that's how we find our profit function. So if you want, you can, I don't want you to memorize this, but if you want to and you feel like you need to, then fine, right? But you have all the tools on your formula sheet to just build this, right? So it might be a good exercise to just get comfortable building this general profit function, because if you're relying on memory, that can be tough, right? Especially in a test when you're trying to remember a lot of things, right? And especially because you have all these components on your formula sheet, right? It's not something that I would want you to memorize even. Right? But if you have it memorized, fine, you can go ahead and use it, right? Even on the test, you don't have to show how you find it every time. As long as you've shown me once on the test that you know how to do it, then you can just go ahead and use it. Right? So I like to be thorough, so I tend to just always develop it every time, but you don't have to. For example, let's do example 100, lucky number 100. So here, this one's a little bit longer to read, but I'll just read it to you, especially if you can't see. Maybe better, but still probably small. Alienware Computers sells computers for $1,000. Right, so now we know how the selling price of each computer. Production costs for a computer total $250. Right, so it costs $250 to make a computer, and they sell each computer for $1,000. Right, already we have two key pieces of information. Rent for Alienware's office is $10,000 per month. Yikes. Determine the monthly profit function for Alienware Computers. We're not going to do this next part. I'll nitpick because it's really tedious and it's just trying to prove a point. I'll just get to the point. But we're going to compute the profit resulting from producing 12, 13, 14, and 15 units and use those to determine how many computers must be sold before Alienware makes a profit. Okay. I'll just do a couple of those, not all 4 of those, because I think you'll get the idea. Okay. First thing we're going to do is we're going to develop this profit function, right? Because now we're given, bling, we're given the price that we're able to sell each computer at, right? That's 1,000. And so that's P. We're also given the cost to produce each computer. That's capital C, 250. And then all we're told is that they have to pay $10,000 in rent each month. So rent would be a fixed cost, right? And so we're told that the fixed costs are 10,000. So we're going to find the profit of X. And I'll show you how I would develop this formula every time. But you'll see you could just use the end values and plug them all in. Doesn't matter. Well, I guess I'll show you here. If you know X, which will be, those are the ones given, the 12, 13, 14, 15. We know P, we know C, and we know the fixed cost. So we could just plug in our values into that profit function, but I'll build it with you guys one more time. So the profit of X is the total revenue minus the total cost. I'll do the substitution in one step because you've seen it now, right? Where I replace the total revenue with P times X and the total cost with the variable cost plus the fixed cost. Oops. Oh, FB. And then P times X minus, I'll do it in one go. Break out the brackets and put in the C times X for VC. C times X minus the fixed cost. Trying to pull a fast one here. So again, I'll pull out this common X and have P minus C minus the fixed cost. So now we've got, now we can substitute our values in, right? P we said was 1,000 minus the cost to produce it is 250 minus the fixed cost, which is 10,000. So 1,000 minus 250 is 750 times X minus 10,000. That's our profit function. So now we can use this to plug in any value of X and see how much profit we make. So let's see, find the profit of 12 units. So the profit of 12 is 750x minus 10,000, where X is going to be 12. So we used that notation before where we had some function and then the X in the brackets is just saying, oh, replace X with 12. And so we get 750, 750 times 12 minus 10,000. I have it here is 9,000 minus 10,000. So I'd make a profit of negative $1,000. Not really a profit, right? You could call it a loss. I like to keep it simple, so you're welcome to call it a loss of $1,000. I'll just say it's a negative profit because I'm lazy, but also because I don't get them confused. But I also just want to save time and thinking in a test situation, right? It's always a profit, can be negative, makes it a loss. So 12 units sounds like we need to make more, right? And so how about we do, how about I find 14 units? Find the profit of 14. So the profit of 14 units is 750 X minus 10,000. 750 times 14 minus 10,000. 10,500 minus 10,000. Woohoo! 500 positive dollars. Phew. So at some point between 12 and 14 units, we went from making a negative profit to a positive profit. So that's something to keep in mind, right? We'll talk about, so there's a little bit of time where it's actually better to make a negative profit than no profit at all. Right? And so there's this kind of not so fun period where you're still taking a loss, but producing nothing would give you an even greater loss, right? So you're still, exactly, yeah. So you'd still have to pay rent, you still have to pay your fixed costs. You may as well produce something. All right. We'll get to that. I got ahead of myself. So let's say we want to make $20,000 in profit. Perfect. How many units do we need? Right. So we've seen this kind of scenario before where we kind of flip back and forth. Okay, so now how many units do we need if we want to make this amount in profit, right? We saw an example of this where we didn't have to make the profit function, but now we've made it and the question stays the same. So if we want to make $20,000 in profit, oops. How many units do we need? How many units do we need? So again, we know our profit function. Our profit of X is 750X minus 10,000. Now we want to force our profit to be 20,000 and then solve for X. So we've got 20,000 is 750X minus 10,000. So now we can rearrange and solve for X, right, by adding 10,000 to both sides. So here we get 30,000 is 750X. So X is 30,000 divided by 750. So X is a nice even 40 units. Nice. I didn't believe it. It's true. 40 units. It's like someone knew what the numbers would do. So now you know, okay, well, if I want to make $20,000, I have to sell 40 units, right? That's not the same as just doing 40 units times 1,000. Then we would feel like we would be making 40,000, but that's not all profit, right? We have to deduct all our costs and stuff. So, any questions about that one? I want to do example 103 just because it's a good exercise just for getting used to working with this function. It's actually not something that I would do to you on a test or anything, but it's just good to have seen it and just get comfortable with working with these, this equation. If a company makes $2,000 profit from selling 100 units and $10,000 profit from selling 150 units, what are the fixed costs? So we're given that the profit of 100 units is 2,000. And the profit of 150 units is 10,000. So far, so good. Okay. And we want to find the fixed costs. We know our profit function has the fixed cost in there. We just don't really know how to get at it, right? Just with these profits. One thing to keep in mind is that this is the same company, right? And so the fixed cost is going to be the same for both scenarios. Okay. So one thing we could do, and there's lots of ways that you could go about solving this. I just want to show you one of the ways, right? But you can play around with it, see what approach you would take. I would probably just start with the general profit function. I'm not going to develop it this time. I'll just use X is P minus C minus the fixed cost. And what I know, if I number these 1 and 2, those two things I was given, from 1, I can translate that into 2,000 is 100 times P minus C minus the fixed costs. There's 3 things in there we don't know, but that's okay. And from the second one, same idea. I know that 10,000 is 150 times P minus C minus the fixed costs. Keeping in mind that the goal is to find the fixed cost, again, there's lots of ways that you could rearrange this and solve for this. I think it might be easiest to just set both of these equal to 0. So what I'm going to do is I'm going to move the 2,000 over to the right-hand side, leaving 0 on the left, and also the 10,000 over to the right-hand side, leaving 0 on the left. Now, I've got both of these equal to 0, right? So then, if they're equal to the same thing, then I can set them equal to each other, right? So that's kind of my go-to move, is I like to set things equal to each other. Right? Lots of ways you could do it. You could use substitution if you wanted to, elimination if you wanted to, but we're essentially solving a system of equations. As long as you think of P minus C as one thing, right? You could imagine an X and a Y, and it would be the same scenario. Right? So what I'm going to do is I'm going to solve for both of these as 0 on the left-hand side. So my 1 is going to be 0 is 100 times P minus C minus the fixed cost minus 2,000. And my second one is going to be 0 is 150 times P minus C minus the fixed cost minus 10,000. Now that 1 and 2 are both set to 0, we can set them equal to each other. We can set them equal to each other. So what I have is I have 100 times P minus C minus the fixed cost minus 2,000 is 150 times P minus C minus the fixed cost minus 10,000. So just keeping in mind that we're trying to find the fixed costs, right? So what I'm going to try to do is I'm going to try to get the fixed costs on one side and everything else on the other side. So, all right, here we go. So we've got, which one do I want to move? I think first I'll move this 100 times P minus C over to the right-hand side. I'm slowly trying to shuffle things over to one side. So I have minus FC minus 2,000 is 150 P minus C. And then I'll sneak in the 100 that I've just subtracted over to the side. So minus 100 times P minus C minus the fixed cost minus 10,000. If I move the fixed cost over to the right or to the left-hand side, from the right-hand side to the left-hand side, they actually disappear, which I'll take advantage of now briefly. Right? And I'll also move this 2,000. Remember, this is not something that I'm expecting you to do. It's just to show you that we can manipulate these things, even if we have more than one unknown. Right? And so we have 100, you know what? 150 minus 100 times P minus C. I'm just going to reduce it to 50 times P minus C minus 10,000 plus 2,000
right? Moving that 2,000 over. So now I have 0 is 50 times P minus C minus 8,000. Can move the 8,000 over. So I get times 8,000 is 50 times P minus C. And so solving for P minus C, treating it as one thing, which it is, right? Just two variables in there. We have 8,000 divided by 50. So then P minus C is 160. Right? So now we can solve for the fixed cost. The fixed cost, we can use either one of these or any one of these formulas, just remembering that P minus C is now 160. So we can take one, for example, 2,000 is 100 times P minus C minus the fixed cost. So 2,000 must be 100 times 160 minus the fixed cost. $2,000 is 16,000 minus the fixed cost. Making some moves here, I'll move the fixed cost over to the left-hand side and then the 2,000 over to the right-hand side. So I get 16,000 minus 2,000. So the fixed cost must be 14,000. Whew. Right. I'll just make a note here. There are many ways we could have solved for this. We did a version of substitution. I set it equal to 0, right? Solved both of them for 0 and substituted them in for each other. You could have used substitution. As long as you use P minus C as one thing, you could have used substitution. But whenever I see a lot of stuff like that and I'm not sure, I usually just set them equal to 0, right? Force them to be 0, set them equal to each other, and deal with that. For me, that's better, but I don't know. Whatever you like. Any questions about that? Okay. Let's talk about the shutdown point. The shutdown point is the point where a manufacturer or a firm is better off not producing anything at all, right? So it's actually costing you money to sell things, right? So it's not costing you, it's different from a loss, right? But now it's actually costing you to sell things. So the shutdown point is the point where a firm or manufacturer is better off not producing at all. Essentially, if the price that you can charge, right? So if the selling price doesn't cover the cost to make a thing, right? You need to shut it down, right? let's say it costs you $5 to make something, but you have to sell it for $2.50. That's not fun, right? You wouldn't keep making those. You would have to sell off the ones you had, pack it up, right? But if I said, oh, I'll pay you $5 for that thing, and you say, oh, well, it actually cost me $10 to make it, that's not good, right? And so if you can no longer cover your variable costs, you have reached the shutdown point. You've reached the shutdown point. So in relation to our profit function, if we have a look at our profit function, profit of X is X times P minus C minus the fixed costs. What we're saying is that if this value, the P minus C, if it's less than 0, right, then it's taking away from your profit, right? Then you've got a negative number times X, the number of units that you're selling. So every time that you sell one, you actually take away from your profit even more. So if this value is less than 0, we have reached the shutdown point. Just as a little side note, P minus C is called the contribution margin. It's not something I care about, but I have it here, so may as well write it down. P minus C is called the contribution margin. Which I guess makes sense, right? P minus C is how much you're actually profiting off of each thing, right? How much are they contributing to your profit? Contribution margin. Sold. So in math terms, right, we've reached the shutdown point when P minus C is less than 0, right? So in terms of the math, the shutdown point is when P minus C is less than 0. We've seen some inequalities before, but just remember, if you kind of make it like this, it looks like an L, so you read it as less than, right? Other way is greater than. I only mention that because I know those are hard to keep track of. So if P minus C is less than 0, then really what we're saying is that P must be less than C in that case. Because we can treat this inequality as an equal sign. As long as we don't multiply or divide by a negative, I'll throw that in there. Doesn't matter in this case. Right. So all you have to check is, or say rather, you've reached the shutdown point when P is less than C. Right. So let's do an example. Example 104. This profit is given by, and now we're given the profit function. Right? P minus 13 times X minus 75. Just from this formula, right, we know that, well, here this 13 must be C, and the 75 must be your fixed costs, right? Because it has that same structure that we're used to. I usually put X on the left-hand side. On the right-hand side of the brackets, it doesn't matter. So the question says, at what market price does the firm shut down? Right? So what is the shutdown point? And then if the price is $1 above shutdown and quantity produced is 10, how much profit is made? So it's a two-part question. And so we'll start by finding the shutdown point. We said the shutdown point is when P is less than C. Right? And so that's why it was helpful to identify that C is 13, right? Because now we say, well, we've reached a shutdown if P is less than 13. We don't know what P is, right? But in general, if P is less than 13, you shut it down. Right? You've answered the question. Shutdown point is when P is less than 13. Moving on. Too easy, right? So now, let the price be $1 above shutdown. Right. So P is 1 plus 13. We decided that 13 was the shutdown point, so $1 above that must be 14. And X we're told is 10, right? And the quantity produced is 10. And we have to find the profit. So we have the profit function. The profit of X is P minus 13 times X minus 75. Now we know that X is 10 and P must be 14, right? That's what we decided. And so we want to find the profit when P is 14, so 14 minus 13, and X is 10 minus 75. Fourteen minus 13 is just 1. 1 times 10 is 10 minus 75. So the profit is negative 65. So even though this is a negative profit, right, it's better than not producing anything else, or anything at all, I should say. So what if X is 0? Then we can say that the profit of 0 is, I'll do 14 minus 13, I'll skip to that, times 0 minus 75. So now we have 0 minus 75. So we would make even less profit, right? And so there comes that idea of, okay, well, there's going to be a kind of not so fun time where you're still losing money, right? You're operating at a loss, but it's better than not selling anything at all, right? Until you reach this break-even point, which we'll talk about. So minus 65 profit is better than minus 75 profit. Right? Neither of them are good. So let's do example 106. I think it is the brewery one. Sometimes you just have to sing. At school. Okay. So here's another one of those where we have to develop the profit function. And what you'll see on the practice test is that question 3, you have to develop a profit function and answer all these questions, right? So this will definitely be on the first test. Labatt's Brewery spends 42 cents to brew a can of beer, all right? The fixed costs associated with producing beer are $450,000. Yikes. The going price for a can of beer is $1.25. Okay? So we know the price that they're selling it at, we know the cost to produce each can, and we also know the fixed cost. Okay? And so first part is, actually, I'll write out what we're given first, but the first part is asking, what is the profit function for Labatt's Brewery? Right, so we have to find this profit function. So we're given some information here. We're given the cost per can is 42 cents. We're given the fixed costs is $450,000. That's a lot. Whenever I do this question, I wonder if it's per month or per year, per day. No, I don't know. Doesn't say. And we're told that the price that they can charge per beer is $1.25. So 1, find the profit function. Do you guys want to develop the profit function or just use it? Let's develop it. It's been a while. Just so we practice a little bit. So the profit of X, just starting with the total revenue minus the total costs on your formula sheet. And then we'll slowly plug in each of these values, right? The total revenue is P times X minus the total cost, which is the variable cost plus the fixed cost. So we have P times X minus, I'll swap out the variable cost for C times X and then minus the fixed cost. And then we can collect like terms, so X times P minus C minus the fixed cost. That's it. Now we can just plug in our values, right? And so profit of X in this scenario is X, which we don't know. P is $1.25 minus C, which is 42 cents. minus the fixed costs, $450,000. So we get X times, or I'll actually write it 0.83X minus 450,000. So that's your profit function. So now, part 2. What is the profit earned by selling 10 million cans of beer? It's a lot of zeros. So part 2, we want to find the profit of 10 million. 1, 2, 3, 1, 2, 3. So plug in 10 million for X. So we've got X is 10 million. 1, 2, 3 zeros, 1, 2, 3 zeros times 0.83 minus, it's making that 450,000 not look so bad. Oh, actually, this becomes, so 10 million times 0.83 is 8.3 million minus 450,000. So we've got a profit of 7,850, or sorry, 7,850,000. Yikes, these big numbers. 7 million sounds pretty good though. Would not complain about that. Part 3, what does the price need to drop to in order for Labatt's to shut down production? And so 3 is essentially asking, what is the shutdown point? We know the shutdown point is when P is less than C. We were told that the cost for each can, right? The cost to produce each can is 42 cents. So when P is less than 42 cents, therefore, if P is less than 42 cents, we have reached the shutdown point. So that's it for that one. Let's just talk about the break-even output. We've kind of mentioned it, right? But the break-even output is where we go from a loss to a profit, an actual profit, right? So from a negative profit to a positive profit where we want to be, right? That's your break-even output. So your break-even output is the level of output where the profit is 0, right? Where you go from negative to positive. So the level of output where the profit is 0 for example, if we do example 108, took a picture on a slant here. Suppose that the price of a good is $25 and the total costs are given by this formula that we are given. What is the break-even level of output? So let's just talk about what we've been given. So we've been given that the price, P, is 25, and the total cost is 85 plus 24x. Find the break-even output. First, we need to figure out what this profit function looks like in order to set it equal to 0, right? Because we want to know what x is for the profit to be 0, because that's the point where we go from negative to positive. So we can start with, right, as it's always safe to do, the profit of x is the total revenue minus the total cost. Okay. Total revenue we can replace with P times X minus the total cost, which we were told was 85 plus 24X. We were also told that P was 25. So we've got 25X minus 85 minus 24X. If I've got 25X minus 24X, that just leaves me with 1x and then minus 85. Bless you. To find the break-even output, let the profit equal 0 and solve for x. So in this case, if we're told that the profit of x is x minus 85, we're forcing this profit to be 0 so that we can solve for x. So x must be 85. All this tells us is that we have to put out 85 units, right, in order to break even. 84 units, we've got a negative profit still. 86 units, positive profit. Fun. If this value, right, wasn't a nice number like 85, right, let's say it was 85.1, technically you can't sell 85.1 units, right? So to make that transition from negative to positive, you would have to sell 86 units, right? So even if your break-even point was 85.1, right, you couldn't sell 85, that's less than 85.1, you would have to go all the way to 86. Right? So if you found x is 85.1, we would need x equal to 86 in order to make a positive profit. Let's do example 109. Oops, if I have it. Oh, I do. Okay, this one's gonna get weird. Whoa. It's all sassy. Suppose it costs $75 per minute to run a TV commercial during sporting events. Furthermore, you've determined that revenues from these television commercials amounts to $125 per minute they air, right? So essentially it costs you 75, but you're making 125, right, per minute. The total cost of creating a TV commercial is roughly $15,000. How long do you have to run your commercial in order to break even? Right? So how long do you have to have it on air for all this to pay off, essentially? So let's just outline what we're given here. So we're given the cost is 75, I'll just say per minute. They're both per minute, so it doesn't matter, but. And the amount that we sell each minute for, right, or get per minute is 125. Again, per minute. And the total cost, which I'm actually going to say is the fixed cost, because we already talked about the cost of 75, but then it gets confusing because it says the total cost. But really what they mean is everyone that you have to, or all the equipment that you have to buy and just space that you have to rent, right? Those would be your fixed costs. And so I'll change this to fixed. Should say the fixed cost, because it's confusing. But I also like how I've cut it out, but it says clearly the profit is this. But it's not clear because it's saying the total cost, so it makes it confusing. But anyways. So the fixed cost, or we'll use it as the fixed cost, the 15,000. And so the profit function, because if the whole goal is to figure out where we break even, we need a profit function to do that, right? Because we need to set the profit equal to 0 and then solve for x. So the profit is x times p minus c minus the fixed cost. Just jumping right to it this time. We're going to try to solve for x. When p is 125 minus the cost, which is 75 minus 15,000. 125 minus 75, we'll say 50x minus 15,000. Let the profit of x equal to 0, 50x minus 15,000. So now we set it equal to 0 so that we can solve for x. That makes that happen. So now we have 15,000. Moving that over to the left-hand side is 50x. So x must be 15,000 divided by 50. X must be 300 minutes. We would need to run the commercial for 300 minutes. That's 5 hours. It's a long time. To break even, anything less than 300 minutes, you're going to get a negative profit. So it's not worth it. Right, so you better make sure that you can run it for at least 300 minutes. Right. That'd be an issue if you're making a I don't know, a Christmas commercial and it's December 15th, you have to try to figure out how to squeeze those 300 or more than 300 minutes in. Right? But anyways, any questions? No? All right. So you can do a lot of these questions. You can do on the, I'm talking about on the practice test. If you want to get started on that, you can do 1. We haven't done 2 yet, but you can do 3. You can do 5, 6, 7, 8, 9, 10, 11. Right. So really, the only ones that we can't do quite yet that we'll talk about next day is 2 and 4. All right. If there are no questions, see you on Monday. And if you still don't have a formula sheet or the practice test, come grab it here. Oh. What was the name of the game? Bears versus babies. But it will be the same.